Hello everyone, this is Brian Estevez with Larkforge Labs. So today we're going to get started with a new video where I'm going to introduce the 52 Pi Ultimate Starter Kit. And this kit I think is perfect for learning about the Raspberry Pi Pico because everything you need is in one box. So from the Pico itself, you can see here, to a variety of sensors. You can see you have light sensor, sound. There's a lot of toys here that we can explore and build projects around. So this kit is really designed to make things easy. All the components are designed to work with the kit. And so you don't have to worry about looking for parts and worrying that they don't work. It also comes with an instruction manual, so you'll see also with the kit, you don't have to make up projects. You can follow along, although there's limited options there. And we don't have to worry too much about that because we'll be walking together through not only those projects, but additional ones that we'll make up along the way. Okay, so this is a pretty neat kit, and if you haven't got one yet, I'll put the comment in the description. You can see here, this is what the kit looks like, and it's filled with all kinds of goodies. All right, so moving along to the next. So one thing when we're talking about learning how to control devices is we need to learn a little bit about what MicroPython is. And don't worry about this part because it's basically a programming language, and it is a specific kind of programming language that's designed to work really well on small devices. It's a simplified version of Python, which is a general purpose programming language that you can do all kinds of things with. And MicroPython is just a smaller version of that that will fit on this tiny device. And so that's essentially what we need. We need a way to talk to the device and to tell it to do what we need it to do. And Python in general is just really a simple language to pick up because everything is in plain words, in English and understandable words. And so it's a good way to get started in programming. And in MicroPython, like I said, is just a simpler version of it, and it's made for controlling electronic devices. So I hope that makes sense and will sort of give you a reasoning behind why we need MicroPython and why we use it. So like I said, the main thing is that we need a way to talk to this tiny computer. And the way we're going to do that is using this software called Thonny. So Thonny is this graphical interface that will allow you to send commands to your Pico 2W and for it to sort of interpret those commands and actually control the devices that we wanted to control. Now, Thonny is good for getting started because it doesn't require too much setup on the user's part. You basically just download a program and you install it on your computer and open it up, and you'll see a window just like you see on the screen here where it says Thonny, and you have your files you can load and so on. So it's cool because it's compatible with multiple platforms, Windows, Mac, and Linux systems. And that's a good thing because many program development environments to write code are sort of limited to one platform, or they work best on one or the other, but this doesn't really have that limitation. And there's some other cool features here too, but the main idea is that it's going to help us to get started without worrying too much about downloading different tools in order to get going. So it's really the perfect bridge to get from our computer to our Raspberry Pi device and then to controlling electronics. So previously, I introduced the Raspberry Pi Pico and why it's a cool device to get started with physical computing and controlling hardware. So you'll definitely need that today. And you also need a micro USB cable, which is the power source that we're going to use to power the device. And you also need a computer. So you'll need Windows, Mac, or Linux. So we're going to be working with Windows today, but just know that all these systems and devices work with either of these platforms. So if you have one of those, you can still download and install and even run the device. So just the walkthrough here is the first step is we're going to get some software. This is Thonny. If you saw the previous video, it was a place where you actually write codes and commands that you will then send to the microcontroller, which is the Pico device. And we're going to download the latest firmware for the device. So this will be from MicroPython. Again, Python is the programming language that we're using, and MicroPython is just a simplified version of it that works well on these small devices. And we're going to set the device to a special mode called bootloader mode. This is basically telling the device to go to startup and allow us to add this new firmware that we're going to get from MicroPython to it, and then it's going to restart and allow us to run our applications on it. And finally, hopefully, we'll get to test. All right, so here we go. So first, you want to just get a sense of how it's laid out. You can see there on the screen that there's this boot select button, and the boot select button is for basically the initial startup mode, setting it there, and also for restarting if you have a program that sort of is in an endless loop or crashes. It's one of the ways you can sort of fix that problem. The other way, which is more advanced, is this 3-pin header. You see the purple arrows. So these this debugging port, this SWD port that's on the device, you'll see one of the purple arrows points to these 3 holes. Well, these 3 pins that come with the microcontroller is basically a direct line into the device that will sort of unbrick the device. So when you brick a device, basically it means that it's no longer responding to applications. Well, this 3-pin header and SW port is an advanced way to basically get your device working in case that it gets to the point where it crashes and you just can't even start up Thonny at all. So that's just something to put in the back of your mind. We're not going to use that today. The main thing you need to use is the boot select button. So, okay, so let's keep going. So again, for the first time setup, we just need to know where that button is. And what we're going to do is we're going to just simply hold that button down. Okay, and while you're holding it down, you'll plug in your USB into your machine. And now you'll see I'll get a pop-up here, right? I can let go of the button. For y'all, you might not see this second file. This actually is because I've already installed the firmware on it. Even though you don't see the file, I've done this in the past. So the thing is still remaining there. But what we're going to do now is open up. First, we can do Thonny. So Thonny is where we're actually going to run our commands and send them to the computer. So we just run and install this, right? Thonny. And again, I'm running this for the second time, so I may get a message that says it's already installed, but for demonstration purposes, I'm running it again. Except, create an icon. I won't do that because it's already there. And install, it might tell me it's already there. Okay. And good, great success. All right, now keep going. So next, now we're on the MicroPython official web page, right? micropython.org. And specifically, we're downloading this firmware. So the first one, the latest one for you, by the time you watch the video, it may be different, but we're going to get 1261, right? Then, now that we have this file, this is key, you will open up that folder. Now that your Pico device is in like flash drive mode, it's basically behaving like a storage device. So your Pico now is like kind of like behaving like a storage device because you put it into bootloader mode. You'll just drag and drop that downloaded file onto your device, right? Now, so that firmware is now on our Pico 2W. When you all do this, it will trigger the restart of the device. And that restart is basically the device recognizing this new firmware, and then this text file will appear for you. So once that's all good, we can open up Thonny. So we'll open up Thonny. Okay. And in Thonny, which is where we're going to write programs, you'll notice for me it says Python 3.10, right? We want to change that to run MicroPython, which is going to help us send commands to the microcontroller or the Pico 2W. So we'll go to, I'll just back up, I'll slow down a little bit. Configure interpreter, right? In there, go to MicroPython, Raspberry Pi Pico, hit install or update MicroPython. When you hit that, it's going to recognize the same folder we were just in that we transferred the firmware to, right? So for me, it's RP2350, the D drive, and you'll see that that's what it's recognizing here in Thonny. So for the family, we put RP2, Raspberry Pi 2, and for the variant, Raspberry Pi Pico 2W, because that's this specific device. The version of MicroPython 1261, which was the latest version of MicroPython we just downloaded, okay? So, and hit install. Okay, now it's all done. You'll see the done sign here, and then just close it out. Now, to make sure this is all working, we want to go back into configure interpreter and go down to where it says port and make sure it's recognizing this new port. For me, it's board CDC ADCOM6. That's the port where it's recognizing the Pico 2W device. Okay, so for you, just make sure that you'll open up configure interpreter again, go to port and select the new one that appears there and hit OK. Now you'll notice here something has changed in the shell, which is the output of the Thonny terminal or the Thonny IDE. So you'll see that it says MicroPython with the version we just downloaded and installed, and it says the device we're using. So it's recognizing that we're using this Pico 2W device now. So it's all good. So everything worked. Now, if you're not seeing that, you might want to have to restart. So you hit the stop sign up here, and then it will reboot this IDE, and then it should recognize. Okay. So we've installed MicroPython, we've booted up our device, and now it's ready to go and ready to control hardware. Alright, so we loaded MicroPython onto the device's internal storage. So now we have a system that can run Python code. So the Pico 2W can now interpret and run Python. And we showed that we also use Thonny because it makes just loading and editing files and interacting with the board way more simple. So let's talk about the parts that we're going to need. So we're going to need two male-male jumper wires that are black and two male-male jumper wires that are red. Male meaning that the pointed end is on both sides. Okay, so we got 2 red, 2 black. Of these flexible jumper wires, if you have something else, that's also fine. And we're going to use a red LED. Notice that one leg is longer than the other. That's important. The red leg is, we want to make sure it's always pointing back to the positive terminal, and I'll just explain that in a second. And last thing we need is called a resistor, and this is to slow down the current coming from the device to the LED so it doesn't burn out the LED. You should know that running too much current into components can burn them out and damage them, or it can damage the Pi itself. So the board itself can be damaged by high current as well as the components. So the way to prevent that is by using resistors and knowing a little bit about how to calculate resistance, but we'll hold off on that and we'll just follow the example for now. So we'll need a resistor. As I mentioned, I have here a 1.5K ohm resistor. So in other words, this is 1500 ohms. And I'll show you very quickly that there's colored markings on this resistor, right? The first one is brown. If we look at this little key here, brown is 1. So this is a 4-band resistor. So we're going to use the 4-band code. So brown is 1. So the first digit on this is 1. The second digit color, we look at the color, it's green. So we look at the second band and it tells us that green means 5. So we have a 1 and a 5 as the first 2 digits, the first 2 bands. Now the third band is red. On a 4-band resistor like the one we're holding, the third band, which ours is red, means a multiplier. So we multiply 1 and 5 by 100. So that 1 and 5 by 100 means 1500. So what we're holding right here is a 1500 ohm resistor, and the last band, because it's a 4-band resistor, is the tolerance. So it just means how far off we can expect its value to be from 1500 ohms. So it's not going to be too far from 1500 ohms, about 5% off, plus minus, right? So bottom line is that this is a 1500 ohm resistor, and that's really all we need to know for now. It's good enough for our purposes, and it will prevent the damaging of our LED. Okay, so let's get started. So the other thing you need to know is the GPIO pins. So for now, what you need to know is the pin we're going to use is the last pin here, which is GPIO pin 15, and then here is the ground pin. So those are the two we have. Also realize that I have pushed the device into the breadboard, which is this white component you're looking at right beneath, right? It has connections that are connecting all the holes to allow us to run current through our components like you would a circuit. So realize that there are pins, physical metal pins, that are under this board and connected to the breadboard. I will just disconnect it so it's easier to understand. So you see that? And so you want to make sure that when you push this into your board, you really push it in pretty tight, because that may be the problem why you cannot see the LED lighting up. Sometimes the board is not pushed in far enough. Okay, so now that we know our setup, let's get started with the connection. So take the red jumper and line it up with the GPIO pin 15. Now that, oh, I just missed it. It would be this one, right over by 1. So, okay, so now we're in the same column. Oh, I still missed it. Jeez. All right, now we got it. It's a little bit awkward, the camera angle here. But I am lined up with the pin. Although it doesn't look that way, you can see if I lift the board up and I drop it back, you can see how I'm in the same column. Okay. All right. So that pin and my jumper cable are in the same column, right? So they're going to share a current. That's how this board works. When two components are in the same column on the main board, which is the center here. So this is the main board. This is the main board. All these pins are on the main board. When they share a column, that means they can share a current. But if they're side by side, they will not share a current. That's just a reminder if you've seen previous videos. If you haven't, you can look at my previous video. So we're gonna run this over here to the rail, so that way anything that is on this rail that we later put will share that current coming from the GPIO pin 15. And we know this is 15 because we have a map of all the pins, and we know that this one corresponds to 15. So now let's do the black jumper cable, and we'll skip one, and we're going to plug it here. This would be the ground pin, right? This is where the circuit will return, and this is the reference point where all the energy in the circuit is going to return back, and it will have 0 volts compared to the red cable, which has 3.3 volts. And we know that because of the data sheet for the Raspberry Pi Pico tells us that the voltage is 3.3 volts from this pin. Okay, so now we have the power and we have the ground. So what else do we need? We need to get the LED onto the board. So for that, I recommend just putting it somewhere that's comfortable, that you can will not have to stretch your connections too much. The most important part is that the long leg of the LED, there's you can see one long leg, that is facing towards the positive end, or the power source, right? On a conventional circuit, the power source. So the red cable. So we're gonna pick up another red cable now and connect. Let's move this to the side so it's a little bit easier to deal with. Let's move our LED over a little bit. Okay, so we just moved it over. Now you can see the leg of the LED is there. I'm going to line this up, this red cable, this jumper cable, with that leg, the right leg of the LED, and I'm going to bring it up to this power rail, right? So now they're sharing power. Okay, so the current from these two top rails, they run side by side. It's the opposite of this main board, where the current runs, if they're in the same column, they share current. So just like the right leg of the LED and this red cable, they're going to share current because they're lined up under each other in the same column. But on the top two rows and the bottom 2 rows, the current only runs side to side. Okay, so that's why here the 2 red cables being side to side, they're actually connected. Okay, so the current's going to go from the board to this red cable over here to the positive rail, into this next red jumper cable because it's next to it, and then into the right leg of the LED. That's how it's going to flow. All right, so let's keep going. Now what do we need? We need a way to slow down the current so that it doesn't fry the LED. So we're going to use what I showed you earlier, which is the 1.5K ohm resistor, or 1500 ohm resistor. Where are we going to connect that? To the left leg of the LED. Okay, so we'll do that right here. Again, I'm lining up the leg of the LED, the left leg of the LED with the right leg of the resistor. The resistor direction doesn't matter, I could flip it. What matters is that it's in the same column as the left leg of the LED. Okay, so just to be clear, this is the left leg, and this is the right leg of the LED, and notice how they are in the same column. Okay, so now we have a way to slow down the current. Now what we need to do is return back to the ground to complete the circuit. Okay, so what do we connect? The left leg of the LED. So we need to get into that same column, right, as the resistor. Get into the same column and go back to the ground rail this time, up here. Right, so now we have a complete circuit. So there you have it. We have a circuit. you can see that there is some current coming through here. It already lit up. So it's actually working. So we were able to light the LED. But the real question is, can we control this with a script? So we're going to do that next. All right, guys. So let's get started with the coding piece. This is often the most fun part because we get to think about how we can control the LED just using code. So if you're not familiar with this, don't worry, we're gonna do this together. So the first piece is you want to make sure that you are loading up the libraries. So for MicroPython, there's a special library we use. And libraries provide us with special functions that built-in Python does not. So the first one we want to use is called machine. So machine lets us interact with the hardware on the Pico device. So like the GPIO pins that communicate with the LED specifically. So to get what the library we need to say from machine import pin. So pin are those GPIO pins that we are trying to control, okay? So now we got that out of the way. We'll be able to interact with the pins. The other thing we need to do is say from time import sleep. Now what's that? That is helping us to add delays between turning LEDs on and off. Sorry about that. There you go. All right, so now we have a way to control timing and to control the pins. After this part, we want to define which LEDs we want to control, right? Which pins we want to control. So which GPIO pins do we want to control? So to do that, you'll create a variable somewhere to hold the information of the pin, and we'll use the pin object we created above, and we'll say pin 15 is going to be an output. So you'll say pin out. Pin out. So now just realize you can change this based on your pin numbering, right? So depending on what pin numbering you have, you will change the GPIO pin number, right? It could, for you, you may have used a different pin, but we use the very bottom left pin on our Pico 2W, which are pin out map, which you can Google for any board, tells us that that bottom left pin is GPIO pin 15, and that's why I wrote 15, okay? So you would need to refer to a map to know what your number is, which if you're using the same board as I am, would be 15 for the bottom left one. Okay. Now, what do we need to do? We need to find some way to tell Python to turn the LED on and off, and to do this in a safe way. So whenever you're repeating something in Python, you would write a loop, which is just a repeated, tells the program to repeat instructions. And you want to do that in a safe way. So to do that in a safe way in Python, you say try. And try means do this and only if there is no error. So try means try it if there's no error. But if there's an error, you'll have an exception. So we'll jump down really quick and say except keyboard interrupt. And this tells it that if there is an error, jump down here and exit the program. Or if, in this case, if there's a keyboard entry. So we're going to tell it if we press Control-C, exit the program. So this will give us a way to get out of the loop, because what we're going to use is a while true, which is an infinite loop, because while true means while true is true, which is always the case. So that will never change. We'll have to exit by hitting Control C, otherwise it will just keep running the program. All right, so next, now that we have started our loop, we need to get access to that pin again we created above, LED pin dot value this time, because we want to read, we want to update its value. Sorry, we want to update the value of the pin. And we want to update it with what? 1, which means turn it on. Okay. Then we'll sleep for half a second here. So this is in seconds. And then we'll print the status. So we'll say that this means LED was turned on. Okay. Now, what do? We want to turn it back on. Off. So what do we have to access that pin value again. This time, can you guess what we'll put here? Instead of on, we'll put off, which is represented by 0. Okay. So then we'll sleep again for the same amount of time. And this time, we'll say that we want to update the status to print LED off. So now we have a way to blink the LED. So just to explain a little bit here, these timings are telling us to wait half a second, and then it's going to repeat this process and then turn it off. So this repeats, producing a blink, and then when you hit Control C, it tells it to get out of this loop. And what we're going to do is here, we're going to have to access the pin again, the pin object, and tell it to, if we're exiting, we want to turn it off, right? But sometimes that doesn't always work. So what we'll do is we'll say pin.init, which means initiate or turn on, to change the mode of the pin to an input. And so basically that's a way to prevent the code from leaving the pin in an on state, which could waste power or harm the pin. So by changing its state to an input, it's another way of turning it off. So we have 2 ways of turning it off. So this is basically a way to clean up your code and prevent things from staying in an on state. So I hope that makes sense. I may have made some mistakes, but let's let it run like this and see if we did a good job here. All right, let's test it out. All right, so we should be looking at the LED now. Let's see. I'm gonna run the program. All right, that was great. So I hope you can see now we have a blinking LED. We were able to code that up in MicroPython, and we were able to use our Pico device to control that blinking. Now, so just to summarize what we did here, we used the machine library, the pin object from the machine library to control the GPIO pin 15. And we used a sleep module here to add a delay between turning it on and off. And this try and except creates a good configuration to cleanly start and stop the LED. So it leaves the hardware in a safe on and off state to allow us to control it without leaving it on. Okay, so one more thing here. Now, if we wanted to, I'm gonna hit Control C now. If we wanted to add another LED, how many people think that would work if we just added another LED here? Well, it turns out we should test that actually. So let's test. So I'm grabbing another LED now, right? So this is an LED right here. And if you remember, I want the positive end facing towards a power source, which in this case is the Raspberry Pi Pico, right? The microcontroller. And all right, so if we wanted to connect this, what would we do? We would actually connect the components end to end if we wanted a series circuit. That's what a series circuit is. It's a circuit where the components are connected end to end. So check this out. I'm going to put another LED here, end to end with the first one. All right? And I'm going to put the resistor back in. Why? Because I don't want to damage the components. I know ahead of time that this is enough resistance for this. Remember, using the 1500 ohm resistor. Now, I will plug in the ground, right? Now let's see. I wonder if this is gonna work. Now we have two LEDs, right? Should work. It's basically just more voltage being consumed, 2 volts each time, right? Why not? Let's run it. So now I'm running my code again. Now you see here, the signal produced is much, much lower. And I'm actually surprised it's working. It's very, very low. And that tells me that this is not the ideal way to run this. Now, we could even go further and put a third LED, and it will be even dimmer if not totally off. Now, why is that? Well, that's because the power source only produces 3.3 volts from the pin. It may be actually producing slightly more than that based on the output here. But, or the LEDs are consuming less than I expected. But nonetheless, the voltage is being consumed, and there's only about 3.3 volts coming out, and each of these lights is consuming about 2 volts. So the total volts that are being consumed by the LEDs is more than the microcontroller could actually put out. Or it's basically most of it is being consumed. So there's not enough power for us to run 2 LEDs, at least in the series configuration where the components are connected end to end. So I'm not going to go into parallel circuits just yet. That's for another video. But we could do that. And I challenge anyone watching this to show me a response in a parallel configuration that would actually allow this to work. So you all can respond in the comments or just try it on your own and tell me whether it worked and you were able to set this up and have it working. But what I'm going to do now is just show you that it's a power issue, that it's literally that we don't have enough power. To do that, I'm going to use this handy 9-volt battery, and I'm just going to switch the power source, right? That will prove to you that it's a power issue. That's the limiting factor here. Okay, so I will stop the program, Control-C, right? Lights off, power off. Now, let's switch the source. Now, I know again that the resistor is high enough to prevent the damage of the LEDs. I know this ahead of time because we ran those calculations. So I'm going to connect the power source here. I'm just going to do it this way, but you can see here. This is not the best way to do it, but I will just do it for the sake of this video to show you that the power source, and there's no harm with doing this, the current's pretty low. You can see here that just connecting it to the 9-volt battery, we were able to overcome the power issue, right? Because now we have way more power going through. In the other situation, we barely had enough because we only had a 3.3 volt power source, and here we have a 7 volt, it would be close to 5 volts total coming through after you remove the power consumed from the LEDs. So you see that it was just a power issue. I hope that makes sense, and I challenge people to come up with another way that we could wire this to use one pin from the Raspberry Pi Pico and still power 2 LEDs. And you can respond here in the comments, and in the next video I'm going to show how you can actually wire that up in parallel. Alright everyone, hope you all enjoyed this. See you in the next one.